lốt 1 2 3 4. Okay. Alright, so on the second part of section 8.2, we continue with our last conic curve. This conic curve we call the hyperbola. And what a hyperbola look like, and how it's come into existence. So let's get started. So second part, hyperbola. Oh, I'm sorry, let me close this. Okay, let me focus this. Here you go. So if I have again, if I have a cone, I have a cone like this. Okay, I have a cone like this. Okay, and I have another cone upside down. Okay, all right. And if I let a plane, a vertical plane, okay, a vertical plane, something like this, it cuts through the cone. Okay, a vertical plane cut through the cone. Okay, and when it's cut through the cone, you will see that it cut two cone at two curve. Okay, cut a cone at two curve. The first curve will be something like this. Well, it's kind of very hard to draw. Let's see, it's going to be something like this. Okay, and another curve could be something like this. There you go. Just imagine. Okay, just imagine. All right. Okay. So these two curves over here, okay, combine, then we call these two curves hyperbola. Okay, we call it hyperbola. And we also have horizontal hyperbola and vertical hyperbola. So what I have over here in this picture is a vertical hyperbola. If I draw the cones sideways, and I have the horizontal plane cut in two cones, then we have a horizontal hyperbola. Okay, so on the first part, I will be talking about horizontal. I think we're going to talk about, yeah, let's talk about horizontal hyperbola first. And I will be talking about the one that the one which center is at the origin, and the one which center is somewhere else in the coordinate system. So it's kind of similar to ellipse also, and even the equation is kind of similar. It's just a little bit different. So for horizontal hyperbola, so I will be talking about, hold on, I tried to mimic what I have last time. Okay, so I will be talking about the one which center at the origin. So so I have a coordinate system like this. Okay. Okay, and I have a hyperbola like this. Okay, oh, I'm sorry, this is not a good drawing. Okay, something like this. Okay. Okay, Again, we still have so if I have a horizontal hyperbola, so it means the OX, the x-axis will be the major axis, okay, and the y-axis will be the minor axis, okay. All right, and over here, the point right here is the vertices. So I will call the point A1 right here, and this A2. And the distance from the origin to those points we call is the A. So this is negative A comma 0, and this is A comma 0. Okay. We also have the focus. The focus will be outside. So I just say over here the focus is here. So this is F1. So F1 is negative C0. Again, we have the relationship between A, C, and B. And what is B? I'm going to tell you right away. And we have F2 over here is C0. Okay. And the B value, and the A value, it helps us to create a box. We call the central box. Okay, we call the central box. Okay, a box that look like this. So it depends on the A value and the B value. The box will be bigger or small, you know. So the B value is the distance from here to here. So over here I will call point B1. Okay, point B1 right here. Coordinate is negative B, 0, negative B. Over here B2 is 0, B. Excuse me. Sorry guys, I still have allergy. So this is 0, the origin. Okay, and we have the equation for hyperbola like this: x squared over a squared, okay, minus y squared over b squared equal 1. So kind of similar to the ellipse, right? The only thing is that the minus over here is the minus over here, and for ellipse it is plus. Another thing is that A and B values, when we talk about ellipse, we consider if A is bigger than B or A less than B, depends on how you name the value under the x and y square over here. But for hyperbola, actually we don't care. We don't care much about A and B. Okay, it could be A over here, the value over here could be bigger than the value here, or the value under the y could be bigger than the value under the x. Okay, and because over here the major axis is A1, A2. Okay, so it looks like the A value is more important than the B value. Okay, the A value is more important than the B value. So we will have 2 vertices only. Okay, 2 vertices only. For ellipse we have you know, I remember I said that we have totally 4, but it depends on each book. Okay, for the horizontal ellipse, actually we have in our textbook we have only 2 vertices. But if I ask you to write out all the vertices for ellipse, then just make sure you write A1, A2, B1, B2. But however, in hyperbola we have only 2 vertices. Okay, so vertices we have only 2 of them. Will be the plus minus A comma 0. Okay, the B1 and B2 we don't call that vertices. Okay, But for b1 and b2 in ellipse, depends on you have horizontal or vertical one. You may call it vertices. Okay. If I ask you to find all the vertices, then you just go ahead and write all of the a1, b2, b1, b2. Okay. And the vertices, again, a vertex is, I will tell you, is that you have a vertical or horizontal ellipse. In this case, same thing. And the vertex, it might help you find if it is a horizontal hyperbola or vertical by hyperbola. Okay. And we have focus is plus minus c comma 0. You have to think about is if you see if they give you the focus in this form, then you know, right, this is horizontal hyperbola. Okay. And we have the relation between a, b, and c, and the relation is much simple. This could be c squared equal to a squared plus b squared. Okay, so I'm going to box this. Okay, I'm boxing this. Okay, hold on, let's just want to make sure that everything's still being recorded. Yes. You know, I don't want to talk for the whole hour, then finally I don't have the video for you guys. So it happened to me before, so that's why I keep constantly checking the recording which app software right there. I just have another software, and so you see that is over here I don't have the benchmark, right? I don't have the mark right over here, so this is good. All right, let me fix this a little bit, and the line is not quite perfect. Okay, well, that's all we can do. Okay, so we have c squared equal to a squared plus b squared. Okay, so a and b over here again. A and b is not a big problem. If you have equation like this, you know that is horizontal hyperbola. You know, a and b value won't tell you like it just tell you which one is bigger. It tell you how big how the box look like. However, it won't tell you that it's a horizontal or vertical hyperbola. Okay. And we also have eccentricity. So eccentricity E will be equal to c over a, always. Okay, so it will be the value c over the value under the x. Okay. And we have also we have Directrix Equation. It will be Directrix Equation going to scale will be x equal to plus minus a square over c. Okay. I don't know if I mentioned Directrix in let's see, in the hyperbola, in the ellipse or not. Let me see. Yeah, I do have for ellipse. I also have the Directrix also, but I never mentioned the Directrix for the center that is not at the origin. Maybe for this one I mentioned that. Okay, so this is the Directrix equation for hyperbola. Okay, and we also have asymptote. See, for the ellipse we don't have asymptote. Oh, I'm sorry, I need to move up. So for hyperbola we have asymptote, so it will be y equal to plus minus b over a x. Okay. Okay. So that is the asymptote. So whatever under the y value, you divide the value under the x square. Okay, but only a, not b square and a square. Okay. All right. So that the asymptote. Okay. Okay. So that is the for the hyperbola. I think the way I give the lectures is a little bit different. Let me talk about the horizontal hyperbola whose which the center is not the origin right now. Then we do example. So last time when we talk about ellipse, so I give you the equation for horizontal ellipse, right? Then I give you the example, right? But this time I think I'm gonna do both of them. Then we do the example. I think that's why it would be. I don't know which way is better than the other. I just want to try a little bit different the way I lecture. Okay, because some of you guys understand the other way. Some of you guys really love this way. Okay. All right. Now for whenever we have a horizontal hyperbola and which the center is not at the origin, we have something like this. Okay, so I'm gonna put over here. This is a center box. Sometimes it's a center rectangular. It's kind of same thing. Again, we still have x and y coordinate system. Okay, and we move the center instead over here. We move the center over here, and if the center over here, we have the major axis will be here. So the major axis is not on axis anymore. So the center right now is center right here. Okay, I think I'm going to call it I. Okay. Okay. All right. And again, we have something like this. Hyperbola, horizontal. Okay. It's not a perfect one, but I'm trying to be perfect. Yeah. Okay. Okay. So we also have a right here, a1 over here, and a2 over here. Okay. And we also have f1 over here, f2 over here. Similar to ellipse, so every time we have the center shifted, then the coordinate of a1, a2, f1, f2 of course could be different. Okay, it's not gonna be like this. It's not gonna be like this anymore. Okay, and how we know that? When you do the problem, when you draw the picture, then you know right away. You don't need to memorize the formula. The formula is a dumb way to learn conic curve because because I just need to change a and b, or I just to change a different value. I can use u and v, then you guys like mess up. Okay, so don't learn about the formula. If you learn by the formula, make sure you really understand it. Okay, so I will have the center box like this. Just imagine the center box is like this. Okay, then over here I will have b1. Over here we have b2 again. I don't know the coordinate for b1 and b2. Okay, because it's shifted already, so it will be changing. Okay, and the equation for this shifted one will be x minus x squared over a squared plus minus y minus k squared over b squared equal 1. Okay, so the I over here has coordinate h and k. Okay, all right, and c square will be calculated based on the a square and the b square, and in this case the a and b, a will be from here to here. Okay, so a will be from here to here, so that's a, and b will be from here to here. Okay, b is very good. All right, and again c square is still equal to c squared is still equal to a squared plus b squared, so kind of the same, but c is from here to here, so this is c. I'm gonna put c, this is c right here. Alright, so this is c. Okay, it's the distance from the center to f2, or distance from the center to f1. So I'm still boxing them. The eccentricity E is still c over a. Okay. The Directrix equation is still the same. Okay. Directrix equation is still the same. So I mentioned that over here. Last time for the ellipse, I just say it's the same, but I don't really write it down. The asymptote is different because it's shifted already. So the asymptote will be this. Oh, I forgot about drawing the asymptote. So the asymptote is basically right here. Okay, and the second asymptote is this. It goes through the origin. So this is the y equal to plus b over ax, and this is y equal to minus b over ax. Similarly, so for this one, the asymptote will be this. You go through the origin and go through the vertex of the rectangular, and it's going to be something like this. And because this is asymptote, so make sure that the curve, it never crosses the asymptote. Okay, it get close to the asymptote, but it never crosses it. And because this is shifted already, so you see everything shifted, so the asymptote is not plus minus b over ax anymore, but the asymptote will be y equal to plus minus b over a x minus h plus k, because we shifted. Okay, that's the new asymptote. Okay, in the ellipse we don't have asymptote, but for the hyperbola we have asymptote. Okay, all right. Let's see, I can make it a little bit brighter. It doesn't work, kind of same. Okay, now let's jump to our first example. Okay. Okay, so we have equation like this: x squared minus 4y squared minus 36 equals 0. Again, you see the equation, this doesn't look like what we have here, right? But we need to manipulate a little bit more. So I put side by 36, right? And both side by 36. It's not nice. The line is not good. Okay. Then divide both sides by 36. So we have x squared over 4 minus y squared over 9 equal 1. Okay, so this 4 is 9. Okay. If we see something in this way, in this form, we know right away that this is in horizontal hyperbola. It doesn't matter. It's a over here. It doesn't matter which one is bigger. It doesn't matter. Okay. So in this case, I can change a little bit more. So it will be 2 squared minus y squared over 3 squared. All right. Okay. Now we're gonna find all the information. So we have the vertices. So the vertices A will be a plus minus 2, 0, right? That's the vertices. Because we know the major axis is horizontal axis, the minor axis is vertical axis. Okay, we can get the C, but in order to get a C, we need to use this one, C squared x equal to a squared plus b squared. So it will be 4 plus 9, 13. Okay, so the focus F will be plus minus square root of 13, 0, right? We can find eccentricity if you want to. Actually, I will ask you to find. And you know, all the tests I ask you to find all information. So eccentricity will be E over C over A. So it will be C over A. So it will be, because E again is all is between 0 and 1 is always greater than 0. So we cannot take the negative. C over A. Okay. So I'm gonna put again. I'm put over here. It's between 0 less than C less than E less than 1. The E cannot be greater than it cannot be less than 0. Always positive. We can get asymptote. So y will be equal to plus minus b, which will be 3 over 2x. Alright. And I also can find the this is directrix. I'm sorry. So now we can find the asymptote will be y equal to this is asymptote. I'm sorry. So it's asymptote, and the directrix will be x equal plus minus a squared, so will be 4 over square root of 13. Yes, 4 over plus minus square root of 13. So this is directrix. Okay, easy. So that's all information we can get. All right. Let's see. I can do something else here. We will learning how to write a hyperbola. So let's see. Okay. Example number 2. Okay. Okay. There's so many ways I can come up with this type of equation, writing hyperbola equation. So you guys have to be very flexible. Okay. Write hyperbola equation. Okay. Okay. Which goes through point M 24, 5 and have asymptote y equal plus minus 5 over 12x. Solution. Okay, so we have asymptote y equal to 5 over 12x, and we know that this is okay, so this is this has asymptote is y plus minus 5/12x, and if we go to 0.24/5. Okay. Phi. Okay. So how are we gonna do this? How do we know? The thing is that how do we know that is this horizontal or vertical one? Actually, right now we just know the horizontal, so I'm sure that this is a horizontal one. We haven't talked about vertical one yet. But after we learn the vertical one, then it is your responsibility of figuring out which is vertical or horizontal you want to write. It depends on information on the problem, on the question. All right. Just imagine you have, what if it's a vertical one? Okay. What you can have? This hyperbola goes through 0.24/5, and we have y equal to plus minus 5/12x. 5/12x. If 5/12 is the slope, right, of the line, right? So 5/12 mean that it's kind of the rise is very small compared. It's small compared to rise over the run, right? Because the run is 12, rise over run, right? So it's kind of, it's not really steep one. It's not really steep asymptote. It's kind of you know, it's kind of flattened down. The asymptote one is 5/12. So just imagine if okay, just if this one is the horizontal hyperbola, so we have something like this, right? And we have asymptote like this, 5, 12, so rise over run 1, 2, 3. So I'm gonna do 1, 2, 3, 4, 5. I do a very small one, so this 0 right here. 1, 2, 3, 4, so 0, 1, 2, 3, 4, 5, and 12 is here. Right, run. So this is 1, 2, 3, 4, 8, 10, 12 right here. So this is this will be the asymptote, right? So this asymptote like this, right? You got this 8 right here, 8 right here. So this is 8, right? 10, 12. So this is 12 right here, right? Okay. So this 12 right here, and this 1, 2, 3, 4, 5. So 5 right here. Rise over run, right? 5/12, right? And if you have the other asymptote, it's going to be something like this, right? So you have a line like this. Let me see, I can have the ruler. Yeah. There you go. I have the asymptote like that, right? Okay. Now, the point M is 24, 5. So 5 right here is 24. Is where's 24? It's 24. This is 12, right? So this is 12. So 24 double. So right here. So 24 right here. So 5/24 is the point right here, right? This is point M. This is point M. So 5 right here. 24 right here. This point M. Just imagine. And I guarantee you that this is must be hyperbola one. Horizontal hyperbola. Because it cannot be vertical. Vertical is going to be somewhere up here. We'll be talking about verticals. Okay? So vertical will be on the other side of the asymptote. It's up and down. So the M is the value, is the point that hyperbola going through. So it must be something like this. Something like, we don't know exactly what it looks like, but it must go through point M. So it must be something like this. Okay. We don't know where the vertices is. We don't know where the F is, but it must be something like this. Okay, on the other side like this. So 24 on the other side, so it's kind of hard to draw. So like this, something like this, right here. So it must be the hyperbola is something like this and like this. Okay, so based on the information they give you in the question, then you know this horizontal or vertical hyperbola. Okay, alright. And now we're going to write this hyperbola equation. So we need to write out the formula first. We need to know A and B. Alright, we need to know A and B. So how we do it? We know asymptote. Asymptote is equal to what? Y equal to plus minus, right? The asymptote is plus minus what? B. Look at that. B, right? I cannot see it. The formula B over AX, right? Plus minus B over AX will be equal, in this case, plus minus 5 over 12x. So I can set up the ratio B over A will be equal to 5 over 12. B is not 5, okay? A is not 12. B over A is equal 5 over 12. The ratio. Okay. Okay. So that is B over A. And the hyperbola go through this point, so we can set up the equation. We can plug them in over here. So the x will be 24, so it will be 24 square over A square minus 5 square over B square equal 1. Look at that. We have a system of equation that has two variables. Okay, so 24 square is a big number, so I'm gonna use calculator. 24 square is 576. So 576 over A square equal to 25 over B square equal 1. So I'm not gonna solve for A and B. As long as I can solve for A and B, then you see that we can get the equation. Okay, so how we solve for that? So from here I can get B. So B will be equal to 5 over A over 12, right? You know, you guys in pre-calculus already. I'm not gonna go back and show you how to do substitution and elimination method. You know, this is a system of equation. Everybody know how to do it, and this is the system, of the nonlinear. So it's everybody know. Actually, we already talked about the last chapter in college algebra. I remember. Okay, so don't tell me that you never learned this. Okay. Alright, so you guys know how to do the system substitution. So I'm gonna substitute this to this. So my equation becomes 576 over A square minus 25 over B square, so it will be 5A over 12 square equal 1. Okay. So my equation becomes what? I keep solving. So, I'm sorry. You guys need to see on this side, and I need to write on this side, so it's kind of hard. So I will have a 576 over A square minus 25 over 5 over 12 square, so it will be 25 A square over 144 equal 1. Okay, so 25 cancel out, so you have 576 over A square minus keep chain flip, keep chain flip, 144 over A square equal 1, right? Because 25 cancel out, keep chain flip, then everything cancel out. So 576 with this is you subtract two fractions, which is the same denominator. So you will have 576 minus 144. You have 432 A square equal 1. So you have A square equal to 432. and you take square root. No, not a nice number, but we don't need it, right? We just need to know a square. Okay, so we know a square already. You're gonna get b squared, so we know that b equal to 5a over 12. So from here I got b squared is 25a squared over 144, right? So I mean what I mean, b squared will be equal to 25, a squared is 432 over 144. Let's see. Oh, of course I have to use calculator for this one. 432 times 25, you divide by 144, give you 75. Nice number. So I got a squared, I got b squared, so I can get the equation. So x squared over a squared is 432 minus y squared equals 75 equals 1, and this is the final answer. Because our job is to write linear, our job is just to write hyperbola equation. We don't need to calculate ABC. Actually, you can calculate. You take square root. You calculate it. You take square root 75. Here you can get C. It's up to you. Okay. Okay. For this problem, if the question is asked you to sketch, they're a little bit hard because if you take square root of 432, I know the major axis is on the x-axis. So 432 give you 20. So it's about, oh, I think I can. So 27.8. So 20.8. So this 24 over here. So this is 20. Right here. So it's your A right here. So your A2 right here. And you can get C if you want to find C. So C squared will be equal to A squared plus B squared, right? So it will be 432 plus 75. So this is some extra job to do. So 432 plus 75, 807. Then you get C will be plus minus of square root of that. So pretty big number. 28. So C 28. C all the way up here. So C, oh, this is 24, right? It's 24. The C right here. It's F right here. That's C. So this is your F2, and this is the curve. So this A2 right here. So the curve will go like this. Here you go. Go through like this, and go like that. There you go. Beautiful hyperbola. There you go. And you can do similarly for the other side, but I don't have enough space. Okay. Everything cool? Alright. So many ways to so that I can create the question like this, but you guys have to figure it out yourself. You mean you read the question, try to use the information, then you can solve the problem. All right, good. Now I'm going to give you example on for the case we have center is not at the origin. So example, let's see, I have this no example not. So example number 1, 2. So example number 3. Let's see, I have those cases or not. All right, very easy, guys. Don't worry, everything will be fine. No stress. No stress. Okay. How about this? Let's see. Just look like I don't. How about this? What if I have question like this? Show that the following equation represent hyperbola. Conic curve is one of the hardest sections. So because the question is, it can be transformed in many ways. You know, I can create my question for you guys. I mean, and like I can create like 20 versions of the question. More than that. So you guys have to be flexible. Use the logic. Okay, don't learn by the formula. That's why I say don't learn by the formula. You need to understand it. Okay. What if I have something like this? Try to create a problem, but the problem, the number must be a nice number, you know. Let's see. All right. I have 9x squared let's see. Okay, so I have 9x squared minus 72x minus 16y squared minus 32y equals 16. I had an equation like this, and I want you guys to show this hyperbola. It means that you have to complete the square. You see, they look like the problem we already done for ellipse. Okay. So let's see. So first of all, I'm gonna group all the term with x together. So minus, I factor this. So you have 16y squared plus 32y equals 16. Okay. So the way I'm completing the square, in this case, I think I'm gonna do a little bit different from last time. Okay. Again, just some students love this way, the other students love the other way. That's fine. I'm gonna do like this. I'm gonna factor 9 out, and over here I factor 60 now. Okay. Then you see this is look, it's a quadratic, right? And this, you take the middle term, you divide by 2, you square it, right? So you have 9x squared minus 8x divided by 2. Divided by 2 give you 4. So 4 squared give you 16. Right? Then you have to subtract by 16. Similarly, so y squared is divided by 2, you 2 squared give you 1, plus 1, and minus 1. Okay. Then you distribute 9 to the first 3 terms, and you distribute 9 to negative 16. 9 times 16 minus 16 y squared plus 2y plus 1. Negative 16 times negative 1, so it will be positive 16 equal 16. 16. Right? That is weird. So I'm gonna stop here a little bit for you guys to process the information. So I distribute it. Okay. You know, if I have the virtual lecture, which is we don't have for this course, then I'm sure that over here you guys will, some of you will stop me. I'm sure will stop me and ask me why, because right now we're doing everything online. So if you don't get this part, you can email me. Okay, actually, well, it's not really hard. You just distribute it. The reason you add and subtract, because you cannot just go ahead and throw 16 over there, right? We don't have 16 originally, but now if you want to write 16, you have to subtract by 16 in order to cancel them out, because 16 minus 16 is actually this is the same as this one, right? If you don't have anything and you want to get something, it means that you have to return. That's what I mean. Okay, so over here you have a 9, so this is a perfect square, so we have x minus 4 square. 9 minus 16, oh, 9 times 16 is 144. So 16 over here, this is perfect square. Well, just 1 square. You remember a square plus 2ab plus b square, so this is what it look like. So plus 16 equals 16. So 16 cancel out, so what you have is 9x minus 4 square minus 16y plus 1 square. Move 144 to the right, so we have like this. Right? Everybody agree? Okay. Now you guys in pre-calculus, so I expect that you guys to be better than college algebra students. So I'm sure that everybody understand over here. I have, because in order to get the form of hyperbola, over here must be 1. So I'm gonna divide both sides by 144. So x minus 4 square. 9 divided by 144 is give you what? 144 divided by 9. 16. Simplified it. Y plus 1 square. Simplified it. Give you 9. Equal 1. There you go. This is horizontal hyperbola. This horizontal hyperbola. I mean, when we talk about vertical hyperbola, I will tell you the difference between two. But right now, this horizontal hyperbola. You know? Actually, the vertical one, the y go in the front, not the x. Not the x. Okay. So you are able with 16 be right here. Okay. Everything is right there. You can calculate if you want to. Okay. You can get the directrix, the asymptote. The asymptote will be what? Maybe some of students confused with asymptote. I'm gonna do the asymptote for you. The other information you should do it yourself. Okay. So the asymptote will be y minus this will y minus this will be plus y plus 1 equal to plus minus what the formula? What's the formula? Go back. We'll have to check the formula. B over a, right? B over a, so b over here, so it will be 3 over 4, right? X x what? X minus 4. That's it. That's asymptote. Okay. All right. So that's what it is. That's what it is. All right. So when you write a equation for hyperbola with the center is not origin, you're gonna do the same thing. Okay. You're gonna do the same thing. You're gonna move everything maybe I should do one, and yeah, let's do one. I think I'm gonna go ahead. Yeah, go ahead, find all the other information for you guys. Let's draw the picture and find all the vertices and the C value and everything, you know, the coordinate of the focus, you know. So right now we know A is 4, right? B is 3. We know the coordinate, the center I will be 4, -1, right? So 4, -1 is something like this. 4, -1. So 1, 2, 3, 4, -1 over here. So this is your I. So the major axis is this. This is your X. Okay. Because A is 3, A is 4, so 1, 2, 3, so the A1. So, oh, let me see. A is 4. Yeah, A is 4. So it will be right over here. So this is your A1. So 1, 2, 3, 4. This is A2, right? Because A is the distance from the center to the vertex. So we know that the hyperbola will go like this. Let's do the B. B is 3. So 1, 2, 1, 2, 1, 2, 3. So the box is this. This is the 1, 2, 3. So this is the box. Okay. So the hyperbola go like this. Alright. C. So we can get the coordinate of the vertex, right? So the coordinate over here will be what? So it'll be -1, right? So it'll be 0, -1. So A1 could be 0, -1. Right? And A2 right here. So A2 will be what? 1, 2, 3, 4, 5, 8. Right? So this is 8. So it will be 8, -1. Okay. C, you had to calculate yourself. So C, you need to find C first. So C squared equal to A squared plus B squared. So it will be 16 plus 9 is 25. So C is 5. C is 5. The distance from the center. So this center. So C is right here. 1, 2, 3, 4. 1, 2, 3, 4. So this is your F2 right here. And 1, 2, 3, 4. This is your F1. Okay. So the coordinate will be what? So will be F1 will be 1, 2, 3, 4. So this is -1, -1. Right? Coordinate right here because it's origin. It's I. So it must be -1, -1. So F2 will be what? F2 will be this is 8. So this is 9, right? So it will be 9, -1. 9, -1. Okay, -1. Okay, here you go. And now you get all the information. Okay. All right. So on the test, I may ask you to write an equation for hyperbola with the center is not the origin. You're gonna do the same way as you do with the ellipse. Okay. All right. You have to practice a lot. Okay. Make sure you understand all the example and practice a lot. Okay. So I'm gonna stop the video right over here for the first part of hyperbola. On the second part of hyperbola, I will be talking about the vertical hyperbola. I'll see you next time. Okay.